It's almost Christmas, the time of year where I do a video that does not match the format of all the other things on my channel. Last year I took the opportunity to show a whole bunch of YouTube channels that I really liked that hopefully the rest of you had not heard of all of them. This year I'm going to attempt a listicle. Ooh. Even if you've not heard the term, you will have encountered the format. It's where you have an article that goes, the top 5 retro computers ever, the top 15 innovations in gaming, and most of these things are terrible. I think there's a reason that This Week in Retro podcast seems to have a regular section where they just take the Michael out of one of these. I'm particularly thinking of the innovations in gaming, which included good games. Because up until that point it never occurred to anyone to make a good game. So am I just going to do a terrible top 5? Well, I'm hoping not, because I'm going to do something that never seems to happen with listicles, is I'm going to set some boundaries around what this top 5 can be. But before we get into the rules and restrictions, because I know everyone loves rules and restrictions, I should say this video is sponsored by PCB. Wait. Sponsor of 50% of YouTube. They also happen to make some PCBs as well. Yes, design your PCB, upload your design, give them money, PCBs come back in the post. That's basically the entire thing. They also do the same with 3D printing, injection molding and CNCing. Make that 3D model, upload it, give money, thing comes back in post. And if you're not the sort of person who likes designing PCBs, but would like PCBs designed by other people to do stuff with retro computers, well, they have a sort of project gallery thing on their website where you can have a bit of a nose at existing projects and order yourself a PCB that you can solder the bits onto. You do have to like soldering bits onto things, though. Okay, let's get into the rules for our list of 5. Right, so first of all, I'm going to lock it to a time period. So we're going to say early to mid-80s, so 80 to 85. Why that time period? Well, because I'm of a certain age and that's when I first started using computers, so yeah, we're doing this time period. And if we don't lock it down to a time period, well then the whole list is completely meaningless. Because yeah, unsurprisingly, a PC from the year 2000 is just a bit better than a ZX Spectrum. So yeah, we really need to put some time bounding around this thing. We're also going to have to put some rules in around what market the computer was aimed for, and we're going to go for the UK home market. And that's because I lived in the UK, and I was a child at the time, so I had very little exposure to the business market at the time. And also in the early 80s, Cray did sell supercomputers in the UK, and I'm not trying to upset Spectrum owners here, but again, a Cray supercomputer, little bit better than a ZX Spectrum, just, a smidge. So that's it, that's the bounding criteria for our list. UK home market between 80 and 85. Now before we get into the actual top 5, because the delaying tactic is all part of the listicle format, I'm going to do a bunch of honourable mentions, things that did not make it into the top 5, that are definitely worth mentioning, and also saying why they didn't quite make it up into the top 5. And let's go with the ZX80 and ZX81 from Sinclair. For a lot of people in the UK, this was the first computer they bought, particularly the more nerdy members of society that just wanted a computer because they wanted to do computery things with it. And they went for the ZX80 and 81 because they were cheap. This is the absolute main thing about these machines, is they were designed to a price point that regular people could afford. But also, as computers go, even for the time period, they are not very good. What these did was broaden access because of their price point. But they had some very significant limitations in that there was hardly any RAM in it by default, so everyone had to buy the 4K expansion pack on the back that would wobble and fall off and crash the machine. Although you could really help that out with Blu-Tack. The keyboard may be the most singularly awful keyboard I have ever used in my entire life. And you might say, well, it's just as bad as the Atari 400, and it's not. It is worse than the Atari 400. The Atari 400 has at least raised little edge in there so you kind of feel on the keyboard where you are. It's still like pressing your fingers into solid plastic, but the 80 and 81 didn't even have the little raised edges around the, well, let's say keys. So you could not tell without looking which key you were pressing. The main thing about that keyboard design is it was cheap. That's what we were going for here, cheap. Not good, cheap. Whilst hitting a minimum spec level that made the thing functionally enough to be worth buying in the first place. And some coders did manage to do an amazing job getting any games to run on this thing at all, because there is a significant flaw. The circuitry handling the display can get access to memory, or the CPU can. They cannot both at the same time. And there's no clever interleaving going on here. So this is why the display flickers so badly as you type, because the CPU is running to detect the keyboard press and handle it, therefore it can't display anything on the screen. Yep, if the CPU's doing something, the screen is not. If the screen is doing something, the CPU is not. And some games got around this surprisingly well, but it's still not what you would call a good feature in a computer. Next, I should mention the Dragon 32, which is a perfectly cromulent computer. It just didn't quite make it into the top 5 because, well, there are other computers that are better than it. At least 5. Now, some people unkindly refer to it as a clone of the TRS-80. I mean, it's much more of a clone of the Coco, if you ask me. But yes, that is a little unkind, because the TSR-80 and the Coco really did just take the reference implementation that they documented with the CPU that they used and, well, implemented it. And Metatoy, the company behind the Dragon, they did exactly the same thing. Although it is worth noticing, yes, the cartridge port is the same as the TSR-80, and if you're doing an implementation around this reference design, of course you're going to use exactly the same cartridge design as the already pre-existing, surprisingly successful computer, so you can, share software with it. And it was basically a perfectly good computer, it just wasn't quite as good as some of the other computers you could buy at the time. Now, some of you, when we get into the top 5, will be thinking, where's the Apple II? Particularly our American viewers. And the reason it's not in the top 5 is we've kind of qualified it out. I mean, yes, it's a 1970s design, but you can still buy it in our time period, but it's not really what you call a British market home micro, in that technically it was sold here, again, into the home, but it sold in such few numbers that it wasn't really part of the British home micro scene. So, but also, even if it wasn't out of bounds based on our rules, it probably still wouldn't make it into the top 5. Simply because, although it's still being made in the 80s, its 70s technology is showing a little bit, particularly in terms of its display capabilities. I'll also mention the Taton Einstein because, if I don't, at the very least, Johnny Blanchard's going to ask me, hey, how come the Einstein didn't make the list? And again, I'm going to use the doesn't quite fit into the whole UK home market thing. Again, it was on sale here. You could technically buy one and have one in your house, but mostly they were sold to businesses wanting to do a bit of microcomputing and developers who were using them to write games for much more popular systems for the home in the UK. But if it was not for it being qualified out, yeah, this thing might actually make it into the top 5 because it's a really good, quite sophisticated computer. And I'm going to use exactly the same excuse for qualifying out the Atari 400 and 800. As whilst both really good computers, they didn't really do enough sales in the UK for us to say, well, they were part of the UK home market. I mean, they were on sale, but I certainly didn't know anyone at the time who had one, or even heard of someone who had a friend of a friend who had one, or a second cousin's former roommate. By putting that qualification in around home market, I don't just mean that it was on sale in the UK and technically you could fit one in your house. It needs to have done enough sales so that you could go into a retailer of, say, computer games in the UK and buy some games for it. For the UK viewers, we can think of that as the W.H. Smith's test. Okay, that's hit the format point of listing a bunch of things that don't make it into the list, without having to go to the trouble of actually ranking them. Now, I probably should just say one more thing about the ordering principle here. Now we said what can and can't be on the list. Now, I'm judging these machines on how good they are at being computers, not how good they are as games machines. As those two things are not the same. Am I going to take gaming into account? Yes, it's a home computer, that's a lot of what we did with them. But I am principally going to focus on how good they were as just a computer. Into that I will factor in their ecosystem, so the kind of software that was available for them, peripherals, etc. Particularly any peripherals from the manufacturer of the computer itself. Right, let's get into our top 5. And in at number 5 we have the ZX Spectrum. Okay, I know putting this at number 5 is going to be very controversial, but Spectrum owners, put your pitchforks down. I will explain why. If this does make it into This Week in Retro, this is the point where I can hear Neil saying to Dave, "Oh, come on, Dave," as Dave argues that this was a bad place to put the Spectrum. Well, as I mentioned before, I was gonna prioritise how good a machine was at being a computer versus how good it was at being a games machine, because again, I don't view these as exactly the same thing. And the Spectrum is a device that was very much engineered to a price point. And it was a pretty low price point too, which is probably the major factor in its success, that and the time that it was released. As in terms of becoming the UK's leading games platform, well, the field was wide open. And with a wide open field and attractive pricing points, well, that meant that the Spectrum really was able to become the successful games platform right out of the gate, which meant that more people targeted games towards it. And with more games available for the Spectrum than any other machine you could buy in the UK, well, that led to more people buying it as a games machine, which meant even more people published games for it. But as a computer, the design decisions made to hit that budget price, yeah, they're not so great. I mean, for example, let's start with the keyboard. For a games machine, the rubber key Spectrum keyboard was just fine. You just need to mash the buttons in time. If you want to do a lot of application use or spend hours word processing something or coding, that keyboard's a nightmare. Yep, use case really matters as to whether you found the Spectrum keyboard okay or not. The problem is with ranking it in terms of how it was as a computer, well, all the things it was not good for are all the things that you're thinking of when you're thinking computer rather than, well, games machine. Admittedly, the keyboard did get better over time. Different models did have improved keyboards. But if you remember, we're only running up to 1985, and in 1985 you just had the original rubber-keyed Wonder or the Plus. We didn't have the 128 yet, and we wouldn't until 1986. Other things that were non-ideal on the computer is there isn't a monitor port, it's RF out or nothing on the original Spectrum. Then your other two ports, a mic in ear that connects you up to your cassette tape, power in, and an edge connector for expansion. You might note there are no serial ports, there are no parallel ports. So you want to connect a printer? Well, yeah, you're not going to have much luck with that one. Sinclair, however, did make their own range of add-ons, which did include a printer, but I should mention that that printer is just awful. Now, essentially it takes a till receipt roll coated in kind of an aluminium powder, and it then uses a electrified head to basically burn the aluminium off the paper, or burn it into it, to make the text that you get to see. And it's just rubbish. You can't really use the output from it really for anything. You're not doing your homework on this one or writing an essay, and you're certainly not going to hand in a CV printed out on till receipt paper. And there was a second printer option from Alphacom, and that thing's basically just as bad. Sinclair did make some other add-ons, but again, they're largely focused on the games here. So we have the ZX Interface 2, which is 2 joystick ports and a cartridge slot, so you can load your games off cartridge. Were many games ever made available on cartridge? No, they were not. Sinclair, of course, weren't the only people to release a joystick interface for the Spectrum. Oh no, some of those interfaces were quite good. Some of them, yeah, really not. The one my friend had consisted of a plug board and a series of fly wires. We had to wire the whole thing up before you switch the machine on. Double check that you'd wired it up correctly, again before you switch the machine on, because if you got it wrong and you switched the machine on, there was a chance your Spectrum was dead forever. Genius. Now, the other major product made available for the Spectrum by Sinclair themselves were the Microdrive. The idea of the Microdrive being it was a rapid digital cassette interface, so it didn't have to do the whole convert it to audio, convert it back again system. So it could, in theory, load data into the Spectrum much more quickly than a regular cassette tape could. You know there's a but coming, don't you? And it's a big but, and I cannot lie. Mostly what the Microdrive seemed to do was stretch the tape as it used it, rendering the thing unreadable. So as a data storage method, it was a bit flawed in that it didn't store your data for very long. There were some floppy disk interfaces available, but Sinclair seemed to leave that to third parties to do. So Miles Corden Technologies, who would later give us the Sam Coupé, a souped up Speccy clone, produced the Plus D interface for the Spectrum, which allowed it to just about make use of floppy disks. You had to use the commands that you would use for the Microdrive to control the floppy drive, as far as I can tell. You also had the Beta Disk interface, which their creator had to create a system called TRDOS, its own little operating system it could load up in order to be able to use the floppy drive. Which brings us on to our next major shortcoming of the Spectrum as an actual computer. It doesn't really have an operating system. What you've got is a BASIC interpreter. Now, there is a sort of kernel subsystem that lies underneath that, because they just licensed the Microsoft version of BASIC like everybody else did, and for each licensee for that, they had to produce their own little kernel support system. And that provided a few basic routines to BASIC that allowed it to load files, save files, etc. Well, that's not really a hindrance to the likes of the Spectrum, where you're mostly a gaming machine and maybe you might do a bit of basic programming. For a lot of computing tasks, not having an OS is, non-helpful. For example, want to load a binary utility into memory? Well, directly you can't. You have to write a basic program that gets that chunk of data off the tape, puts it in memory somewhere, and then tries to execute it. Want to copy some stuff around? Well, no, you're going to have to load a special utility for that. And this makes dealing with alternative kinds of filing systems or storage actually really quite difficult for the machine to do. You have to effectively patch that little kernel.sys set of routines to hook in support for your stuff. There's no operating system there that iterates through the different storage devices and filing systems, because there isn't really an OS there. Now, one last thing I do want to talk about is its graphics subsystem, because in a way that was quite good for the time, but also quite flawed in other ways. Its display has a decent resolution. It also has 16 colours available at once, but how those colours work, well, that's the very far from ideal part. So the Spectrum has a 1-bit per pixel model, which means you can switch a pixel on or off. But I did mention before that it has colour. Well, colour's not as related to pixels as you might assume. Colour is in fact not stored with the bitmap at all. In fact, the way colour works is effectively if you overlay the grid of characters over top, 8x8 pixels, your colour is set per character. So you can set a foreground colour and a background colour, and if your pixel is in that 8x8 block, if the pixel is on, it gets displayed as the foreground colour. If the pixel is off, it gets displayed as the background colour. And this is where the Spectrum's colour clash issues come from, because as I say, a sprite moves over the background, well, you can only have 2 colours in the same character block, so your sprite either ends up changing colours or your background ends up changing colours. Now, skillful programmers did learn a way to work around this limitation, but yeah, this really is a limitation in hardware. And while you can think of it as part of the aesthetic charm of the Spectrum and its games, it truly is not a great feature of the Spectrum. So hopefully some of you now understand why this is at number 5, because yes, if this was the best British gaming machines from this time period, then the Spectrum would be a lot higher up the list, but it's not. It's the list of the top 10 best computers in the home market in the UK in this time period, and as a computer, it's just not as good as the other ones I'm going to list above it. So, in at number 4, we have the Acorn Electron. Oh god, the Spectrum owners are going to come for me in the comments. The Electron was Acorn's entry into the budget end of the home system market. In fact, it was going to be their game system. But Acorn being Acorn, even when they're trying to make a gaming system, also made a surprisingly good computer. In fact, I think the compromises they made in their design, in terms of trying to hit the price point they wanted to sell it to, compared to Sinclair, if you wanted a computer, they were a better set of choices. So let's start with a quick look around the machine. For a start, it has a really good keyboard. I mean, it's not just an okay keyboard-like keyboard, it's actually genuinely quite nice to type on. And I know this might feel like I'm labouring the point here, but the keyboard is how you interact with the machine. Everything is text and keyboard input with these computers. We are not at the point where any home user is using a GUI as their day-to-day thing. So the quality of keyboard really does matter in terms of using your computer as a computer. And I think the Electron may have, in this budget end of the market, the best keyboard of any of the machines out there. We have RF out, so you can plug into, your regular TV. After all, it is a home machine. But we've also got a proper monitor port, so we can connect a decent monitor or RGB SCART output into a TV that had such fancy things back then. There's also monochrome composite out as well. And then the final port is the cassette port, which has your audio in and out pins, but also a way to stop and start the tape player as well. Now, depending on which Acorn Electron you ended up in your pack with, you either have just then this big expansion connector on the back, or it came with the Plus One, which gave you a number of other ports. So we got a printer port, an analog joystick port, and these 2 cartridge slots at the top. Technically, the Plus One is an expansion, so you may feel it's a little unfair to include it in the initial description of the machine, but it was so common to sell the Electron with the Plus One that everyone I knew as a kid who had the Electron also got the Plus One with it when their parents went and bought it from Currys. I think Currys just sold it as one thing, the Electron and the Plus One bundle, with a pair of some of the worst joysticks I have ever used in my entire life. Now, for the budget end of the market, this is a really good home computer. We'll come back to its ability to run games later on, but as a computer, and this is where we're judging it and ranking it, remember, it's surprisingly sophisticated. For a start, it ships with the best version of BASIC that was available in the 1980s, BBC Basic. And you might be thinking, oh hold on, come on, that's just a preference. No, not all BASICs are made the same. Now if you've seen much BASIC code, you may be familiar with the sea of go-tos that it often became back then, as in terms of jumping around in your code, most BASIC implementations didn't provide anything more sophisticated than that. GoSub was about as sophisticated as it got, but BBC Basic, on the other hand, provided functions and procedures, so your code could define a function and other bits of code could call it and get values back, you know, like you would in any modern development language. And this thing for BASIC was a real game changer. There is a huge difference between using BBC Basic and other BASICs in terms of the sophistication of the program and importantly its structures that you can use. BBC Basic also provided a way to draw stuff on screen, and you might be thinking, surely they all did. No, they didn't. Many of them provided a way to do text. That was it. If you wanted to do some graphics, well, you were going to start peeking and poking values in and out of RAM. It had support for doing sound too. Amazing. A version of BASIC shipped with a machine that supports, you know, all its graphics and sound features. You know, all things the version of BASIC that shipped with the Spectrum kinda didn't do. And on the assembly front, the Electron also has you covered, as BBC Basic has an assembler just built in. So you could write code that was a mixture of assembler and BASIC. Run it, it would assemble your code, and then you can call the machine code. Or if you were only doing a machine code program, you just do all your assembler in BASIC, run it, it assembles the output, take that, save it, and then just load and run it. At the budget end of the home computer market, nothing else did this. There was no other machine that shipped with a sophisticated version of BASIC as this, and with all the assembly tools you need. Again, just shipped with the machine. The other thing we should probably talk about in terms of this being a good computer is it has an operating system. Now some of you will be thinking, but all 8-bit machines had an operating system at least of some description, right? Well, no, quite a lot of them just had a basic interpreter with some very low-level machine code functions for doing basic I/O. And those functions are basically the hardware abstraction layer for the basic interpreter. But for the Electron, things are very different. Its operating system is much more akin to, say, MS-DOS or CP/M, only it's all in a ROM. Now, you still have the same basic is available and works the moment you turn the machine on thing, but whenever you typed into the prompt a star command, so-called because you prefix it with a star, that's a command to the operating system. Anything else you type in that does not begin with a star, that gets passed to whatever the current language is. In the Electron, by default, this is BBC Basic. But if you added another language ROM, say via the ROM cartridge slot, then that can be whatever language is in there. And it's relatively noticeable that the machine starts up a bit differently to other machines. On PowerOn, it's not just starting up the basic interpreter, it actually starts the OS, and the OS is responsible for checking a few bits of hardware, going through all the ROMs installed in the system, and we'll go on to the ROMs thing in a second, working out which one of those ROMs are language ROMs, and then starting up the default language. And then we'll see the machine prompt at the top of the screen, which will tell us which language it's brought up. Now, the OS itself is as sophisticated as at least CP/M or DOS was. In fact, in certain areas, maybe a little bit more sophisticated, at least compared to the version that was available at that point in time. So the OS supports multiple different filing systems, and you can have filing system ROMs in the machine. The Electron comes with 2 built in. The cassette filing system, which unsurprisingly lets you do things with the cassette, and the ROM filing system that lets you store files in a ROM. That's how the ROM cartridges tended to work. Being a real operating system, we also have the ability to manipulate files and the properties of files. So this is why the OS, for example, can produce a catalogue of all the files on the tape, if you're willing to wait long enough, or almost instantly all the files on the ROM. And with certain add-ons, all the files on your floppy disk. The operating system could also be expanded through other ROMs. There were utility ROMs that provided extra commands to the operating system. The OS also provides all the kind of facilities you'd expect for manipulating the machine, setting screen modes, changing things like the baud rate of your serial port, those sorts of things. And being Acorn, of course, all these things were supported in BBC Basic, as you have the OSWord and OSByte commands that could be used to send stuff to the operating system to do things. As on other home 8-bit systems, if you wanted to have Basic do something to, say, some of the hardware, well, then you were going to start peeking and poking bytes into RAM and figuring out how to drive the hardware directly yourself. With BBC Basic, you just looked up in the manual the OS call you needed and the parameters it took, and then you'd use OSByte and the number for the procedure and pass in the arguments and away you go. I'm hoping what you're getting from all of this is that the Electron is much more of a computer for computer users, not so much a games machine that happens to be implemented as a home computer. Now let's have a little look at the ecosystem around the Acorn Electron, because it's got a pretty good one. Now, being a cut down version of the BBC Micro effectively, it benefits from a huge library of application software and utilities, and it can use a lot of them. It can't use all of them. I'll quickly get into why, and that's because it's missing something known as Mode 7. The BBC included a teletext graphics chip in there, which was extremely useful for applications, because what it let the BBC do is get a surprising amount on screen using very little RAM, as you could do quite a lot of, let's say, graphics using the teletext graphical characters that's in the teletext font set. Now, the Electron just doesn't have that, so you can't use any of the software that was super reliant on Mode 7. If you try and access Mode 7, the machine doesn't just explode, it implements a text mode, but it doesn't do any of the teletext graphics or control characters, so stuff kind of just looks wrong, and that does basically break all but the most simple use cases of this. So for a lot of these, we just got an Acorn Electron version of that application, which was an updated version of the Beeb application, just avoiding using the Mode 7 thing. Acorn Soft also made sure that all their primary applications just worked on the Electron, so View, Viewsheet, etc. They worked. We had versions of them for the Electron. We could get them on tape, or we could get them as ROM cartridges to go in the +1. The advantage of the ROM cartridge version being that we had all of the Electron's 32K of RAM for the data for the application, and the application lived in the ROM. So in terms of printers, you can use basically pretty much any printer out there, because it's just got a Centronics port. So dot matrices, daisy wheels, etc., even laser printers. Admittedly, those laser printers cost more than the house you were living in, but they were a thing. Acorn also produced add-ons for the Electron, including an entire floppy disk unit known as the Plus3, which gave you a 3.5-inch drive and a connector that let you attach an external 5.5. In the Plus3 came a filing system ROM to allow it to read and deal with the disk drive, known as ADFS, and this again, for the time, very sophisticated disk filing system, in that it allows you to have directories and subdirectories like we would now on a modern filing system. Whereas a lot of 8-bit micros at the time, you just had a flat filing system. In fact, DOS got through a few versions before we got hierarchical disk structure. In fact, the Plus3 was the first outing for this filing system for Acorn, and later they'd shove it in their BBC Master, and an updated version would appear in their later Archimedes series of machines. There was also an incredibly large third-party hardware manufacturing scene as well for the Electron, most of which seemed to be geared around adding back in the ports and facilities into the Electron that didn't make it from the BBC, which meant if you had one of those things that gave you the ports you were missing from the Beeb, then you could suddenly start adding BBC add-on hardware to your Acorn Electron, like a hard disk or a network interface. Acorn also did create some hardware to add on to the Electron with BT that were aimed purely at the business market. So there's an add-on for the Electron that adds a modem and other things in that would package together to become what was known as the Interflora terminal, used by the network of florists to send orders between the machines. There was also a Merlin branded terminal that BT would ship out that again is an Electron with a modem box kind of bundled on the back that let it get stock information, etc. There were a number of banks that would have them just out on the floor so customers could use them. Now let's quickly have a look at the whole game thing, because I said I'd come back to it, and it does have quite a decent games library. Most of them are games that were also available on the BBC, as it could play a lot of the BBC's game just straight out of the box, and a few needed modifying for the Electron, and that includes quite sophisticated games like Elite. But in order to hit that price point, the Electron does have some performance issues. It can only get into its own memory 4 bits at a time, so it takes 2 CPU cycles for the CPU to actually read a byte from memory. From ROM, it can do it in 1 CPU cycle. So the OS, the basic interpreter, etc., those things do tend to run faster than things that's running purely from the Electron's RAM. And that did hurt its performance as a games machine, but given that the 6502 was clocked at 2 MHz, it didn't hurt it that much. Graphics-wise, it had a number of resolutions that it could run at, some fairly high resolutions for the time, at 2 or 4 colours, and then some lower resolution modes that could run at 16 colours, well, sort of 16 colours, because a number of the colours are flashing combinations of 2 of the other colours. It can be used as like a cheap sprite animation. Honestly, I don't think this was a particularly great idea, but there we go. And we even have a sound chip too. All in all, the Electron is a pretty good compromise on trying to get a good home computer at a budget price point, and certainly from a computer standpoint, the trade-offs made in the Electron were a better set of trade-offs than those made in the Spectrum. Trading some performance in terms of memory bandwidth for the CPU was a better trade-off for the user experience than, for example, the keyboard trade-off in the Spectrum. The losing of Mode 7 teletext was again a better trade-off than the attributes mode color clash thing in the Spectrum. And this is why I put the Acorn Electron at number 4 and the Spectrum at number 5. And at number 3 we have the CPC 464. The first computer in this list to be sold by the foot. The poor CPC never seems to quite get the love from the retro community that it deserves. And I think because in some circles it's seen as a little bit of a soulless machine, and I think that's because it was developed by Amstrad, a company that made an awful lot of things. So to it, the CPC was just another product. And that seems particularly true of its rather well-known, or at least in the UK, managing director, Courtney Geezer, Alan Sugar. All the other machines in this list so far have all been from companies set up by people who were, well, nerdy AF and really liked computers. So I think that's why some people might be surprised to discover this listed at number 3, as they may not ever have given the CPC much thought. Now, time period wise, the CPC just about makes it in, being released in 1984. So it just sneaks in before our 85 cutoff. But that slightly later date did give Amstrad the chance to see what else was in the market and target their machine into where they saw a gap. And that was, they were going to build a machine that could be used as a games machine, but also for people doing business stuff at home. Hence we get a fairly competent actual computer. Again, with a quick look at the thing, we get a pretty reasonable keyboard, a built-in cassette drive so we don't have to worry about obtaining our own one, and twiddling around with volume knobs and the likes. Its only output display is the monitor port. Yep, it came with its own monitor, so you didn't have to worry about sticking a UHF modulator in here or a composite out. We have ourselves a joystick port, a printer port, and an expansion port. And for a first from our machines listed so far, we actually have an audio out port that's not for the tape, but gives us somewhere we can plug in external speakers to our sound chip. We have ourselves a Z80 processor and 64K of memory, which is the most amount of memory in any of the machines we've covered so far. Graphics wise, it's also the most capable machine we've referenced yet, as we have a low resolution mode with 16 colours, chosen from a palette of 27, a medium resolution mode with 4 colours, and a higher resolution mode with 2 colours. And sound-wise, we have a General Instruments AY3 8912. The CPC was a pretty good games machine, but we're looking at it as a computer. And from that point of view, we have a pretty decent BASIC implementation in here, Locomotive BASIC, which has a lot of similarities to BBC BASIC. And that's because it is sort of related. Acorn did start to get other companies to implement BBC BASIC for it, running on other processors than the one they shipped in the BBC Micro. And Locomotive developed something called Mallard BASIC for Acorn, and that was a version of BBC BASIC for a Z80 CPU that you could run under CP/M. And the version of Locomotive BASIC that shipped with the CPC, well, that was based on Mallard BASIC. So we have ourselves a pretty decent development environment. We also have an operating system available for the machine in the form of AMS-DOS. Very early into the CPC's life, Amstrad also got out a disk drive for the system. And with that disk drive, they shipped CP/M. So this is the first machine on our list where CP/M is a manufacturer-supported thing, and is a big part of why this machine is at position number 3. Because thanks to CP/M, there's an entire plethora of applications, utilities, development tools, all available for this platform. So hence it's a very good machine to be a computer, because we can do all these things with it that we can't so easily with the others, because we have the whole library of CP/M's programs and utilities available to it. Now admittedly, by 84, CP/M was on the decline a little bit, as MS-DOS had started to eclipse it in the business space. But as a home computer, this is still a very powerful thing to have, and hence position number 3 on the list. I bet you're all wondering which machine's going to get number 2. Well, it's the Commodore 64. Now, the C64 is best known as a games machine, and it is extremely well suited to being a games machine. It has the best graphics and sound of any of the machines we've listed so far, It has a 16 colour display drawing from a palette of 16 colours, and I was surprised to discover that only one of those colours is brown. It's also the first machine here to have hardware sprites. Its sound chip, the SID, is one of the best regarded sound chips of any home computer of that period, and there is a good reason for that. It's powered by a 6502 or a variant of it, clocked at 1 MHz, and it has, unsurprisingly, 64K of RAM. Hence the name of the machine. In terms of the physical machine, we've got a pretty reasonable keyboard, a cassette interface, a serial interface, which can be used either for printers or discs. We also have a cartridge slot, which can also be used as like an expansion port as well. So what out of all these things makes this machine a really good computer, and not just a really good games machine? And the answer to that, I'm afraid, is going to be a little bit more woolly than all the other definitions I've given you so far. Because the reasons this, outside its graphics and sound capabilities, come much more to do with the ecosystem around it than the machine itself. Because it sold just so darn well in the US, it means that for pretty much everything you want to do computer-wise with the C64, you can do it because someone's either written the software to do it or created some hardware add-on for it so that you can do it. So any computing task you want to have happen, you can make happen with the C64 without having to, write it yourself. But the machine does come with a whole bunch of built-in inherent limitations that really, as a user, bite you in the arse, and C64 owners didn't seem to really mind this stuff too much. But it's definitely what's keeping this machine off the top spot. Let's take its operating system for example. It doesn't really have one. It's got a basic interpreter, and again a couple of low-level binary functions in its kernel. For a machine that's all about graphics and sound, amazingly its basic language has no support for either graphics or sound. Yeah, if you want to make use of those hardware sprites in BASIC, well, you're just going to be poking values into RAM. Or if you want to display anything that's not a character on screen, poking values into RAM. Yeah, this thing ships with the same version of BASIC, and I mean literally the same version, that the Commodore PET shipped with. The machine that doesn't do graphics or sound. And that's all because Jack Tramiel didn't want to have to pay Microsoft any more money. But you can see other ways that this bites the C64 in the posterior. For example, let's have a look at how we use its hilariously awful floppy drive. And don't worry, I am coming back for that floppy drive. Say you want to get a list of the files that are stored on your floppy disk. Normally with a regular operating system, you just, list the files. Oh no, not on a C64. On a C64, you tell the BASIC interpreter to go load a BASIC file off the serial port that we've got the floppy drive plugged into. You don't tell it the file name, and it returns back to you a BASIC listing that has a list of the files that are stored on the disk. Yet for people who have not used the Commodore 64 before, let that one sink in. I know many of you are wondering how the hell is this number 2? Don't worry, I will swing back to that. Now before you probably notice me say, and load it from the serial port, because of course the floppy drive is plugged into the serial port, which makes this the most singularly slowest floppy drive of all the floppy drives we've mentioned today. Now you may be wondering, why did they just not put a disk controller on the C64? Well again, it's so that they could use stuff from the PET, because that's how the PET floppy drive worked. So you could connect PET floppy drives up to your C64. I mean, they were substantially larger than the C64, but you could plug them in. Fortunately, Commodore did make a reasonably sized floppy disk drive for the C64, but it had to work the same way as the PET one did. And again, for the non-64 owners, wait you hear how the floppy drive works. The floppy drive is not a floppy drive in the sense that we think of it for any other of the 8-bit machines from this era. The floppy drive is actually a separate computer. Yep, inside the Commodore's floppy drive unit is a 6502 microprocessor, memory, and the drive control that they should have put inside the Commodore 64, and a serial interface and a ROM containing the software that it boots to allow it to be a floppy drive. So this is how you end up with an incredibly expensive and yet incredibly slow floppy disk system on the Commodore 64. Now C64 owners will be bouncing up and down wondering why I've not mentioned fast load yet, and now's the point where I'm going to mention it. So you could make this whole situation less sucky, and things like the Epic Fast Load are example of this sort of thing in use. And these fast load systems, they essentially replace the software running inside your floppy drive. Because the floppy drive's a computer, so we can do that, right? And some of these utilities should give you about 4 kilobits a second more. Notice I said bits, not bytes. So this is a significant speed up for the C64, but compared to everyone else's disk subsystem, it's still slow as balls. Now, you'd think these sorts of things would have pushed the C64 further down this list, but the The simple ubiquity of the machine meant that for all these problems, there are solutions, there are workarounds, and some of these solutions and workarounds actually turn this into a really good computer experience for those wanting to use it as a computer and less of a games machine. For example, got no operating system? Well, GEOS is a thing. We have a GUI-based operating system we can run on our Commodore 64. If floppy drive system's rubbish, well, there's workarounds and things for that too. We even end up with hardware accelerators for this thing, so we can substantially turbocharge the thing. If we were just looking at the machine in isolation, no, the C64 would not be in position number 2 here. But I did say at the beginning that we weren't going to look at these things in isolation because these machines are never used in isolation, so the ecosystem around it matters. In the case of the C64, it's the ecosystem that got it to position number 2. So, the big question remains, which computer got the top spot? Which one is number 1? If this list does actually get covered on This Week in Retro, what will Dave's reaction be? Have I built up the tension sufficiently as the listicle format demands? Dramatic drumroll. It's the BBC Micro, which to people who regularly watch my channel, this may come as no surprise. Also, maybe having the Acorn Electron at position number 4 and having not mentioned its bigger brother yet, is probably a bit of a clue. Now, for those of you not familiar with the BBC, and that's probably mostly my American viewers, it's an 8-bit micro made by Acorn that was basically ubiquitous inside schools in the UK, but also was aimed at the home market as well and sold reasonably well into that space. Admittedly, reasonably well to slightly well-off middle-class people. Us working classes had the Acorn Electron. I know my place. Ooh, first TW3 reference for this video. So let's get straight to the why the top spot then. Now let's start with the BBC Micro is not built for games. It never was. It does run games and it has a lot of really good games, and no one should die of shock that this is the platform that Elite started on, but its creators were not thinking about let's get a home gaming machine together. They started off by trying to create a computer for the scientific lab world, which is what most of their previous machines had been, but they had realised that there was a wider market for computers developing for the home. And of course, the BBC was looking for a machine, so their Proton machine was tweaked to match the specs of what the BBC were looking for, a machine that could be used in schools and the home. And this gave rise to a really good computer for doing computing stuff. First up, it has the best keyboard of any of the machines here, and also the most robust keyboard of any of the machines here. This thing can survive contact with a child who's just down the sherbet fountain, is experiencing a pure sugar high, and has now decided the keyboard of the computer in front of him has to die. The fury with which a 5-year-old can type, who's just being told he's doing a maths game rather than a game, is a sight to behold. But the BBC's keyboard could take that kind of a pounding and yet still be a good typing experience. In terms of ports, and this is going to be a long list, it does seem to have one for pretty much every occasion. We have a UHF out, so you can plug it into a TV. We have a monochrome composite video signal. There's an RGB port for connecting to proper monitors. There's an RS-232 serial port. There's the cassette port, which again, like the Electron, has all the signals including tape, stop, start, all on the one port. We have the analog port, which many refer to as the joystick port because that is where you put the joystick, but this thing basically an analog to digital converter that will convert any analog signals that we can put into it within its voltage and current limits. On the underneath, yes, we have connectors on the underneath the machine, we have the disk drive port, which you can use to connect any Shugard standard disk to. We have the parallel printer port, the user port, the 1 MHz bus port, which you can think of as like the expansion port on all the other machines we've looked at so far, and finally the tube port, which we're very much going to come back to later. There is also a power output port underneath here, which was intended to be used to power your floppy drive, which provides 2 5-volt and 1 12-volt output. As brought up before, the machine unsurprisingly ships with BBC Basic, which is basically the best BASIC that was available for the time, and in fact also one of the most rapid BASIC implementations for the time, at least on the 6502, which is what's in this machine, clocked at 2 MHz. Which makes this a pretty rapid machine for the time. It also doesn't have any weird memory contention things going on like in the Acorn Electron. Yes, we can read all 8 bits from RAM in one cycle. There's also no weird bus contention thing going on between the video stuff and the CPU, as really we clock the machine at 4 MHz, so it's 4 MHz capable memory. It's just on one clock tick, the CPU gets access to the memory. On the next clock tick, it's the video chip's turn, which means CPU performance-wise, we're about twice that of the Commodore 64. Its other key advantage for being, an actual computer is that it has an operating system, like a real proper one. Now, I cover this talking about the Acorn Electron, so I'm going to try and not recover all the same ground here, but it is easier to show off some of the features with the BBC than it was with the Electron. So if we open the machine up, there are a number of ROM slots in there, where we can have our multiple filing system support ROMs. So we can have a DFS ROM for doing the disk filing system. There was also a ROM available so you could read MS-DOS floppies, but the one I'm going to highlight is the NFS ROM for the network filing system, because yes, you could genuinely network BBCs together. I don't just mean link it to another machine with a serial port and transfer some files around, although there was an option to do that. I mean like a genuine LAN. Acorn had something called Econet, which, assuming you had all the ICs fitted in the machine, meant your BBC could be part of a LAN, and there was a whole file and print service available so you could store files on a remote machine. But it's not just file and print. As I said, it's a proper LAN with network addresses, station addresses, broadcast, unicast. Thus, it could do a lot more than just basic file and print. I mean, there were countless services available for it. One BBC could even remote control another BBC, or just capture its screen, or send it notifications. You could use Econet to allow one BBC to live debug code that was running on another BBC. And while Econet was by and large there for the schools market, I do know people who back in the day used it at home. One example was a developer who would use one BBC to debug the code he was running on another BBC. Another I know, his company had put in BT Killerstream line, which is an X21 lease line, had bought themselves an Econet Killerstream bridge, which let him connect his home Econet network, which admittedly just had the one machine and the bridge on it, to the university's Econet network, which meant he was able to work at home just like he was at the university. And in fact, thanks to some X25 gateway software the university had running on their Econet network, he was in fact able to log into mainframes and other large computers in a number of different universities across the country, all without using a modem. The BBC had basically every development language under the sun available for it, a lot of them provided by Acorn Soft, Acorn's in-house software development arm, which meant you could just install various language ROMs into your BBC and have it boot up into, say, ISO Pascal, for example. Now, if we get back to the graphics for a second, you do have all the same graphics modes we mentioned with the Acorn Electron, as well as this Mode 7 teletext thing I mentioned earlier. But this meant the BBC was also able to connect up to services like Prestel that relied on ViewData, which was basically the teletext graphic and control set, just running over a modem rather than coming in with your TV signal. It's the same thing that Minitel used as well, and this meant for a home computer, you could dial into a number of official government services, banking services, all from home with the simple addition of a modem that you plugged into the RS-232 port. Now, it's not the only platform that could access this, but it was certainly one of the easiest ones to do it from. And speaking of teletext, there was also, from Acorn, a teletext adapter that you could plug into the 1 MHz bus, which allowed you to get teletext directly to your BBC. But it also had another neat trick up its sleeve with regards to the teletext system, and that's something called Telsoft. The BBC, as in the broadcaster, rather than the computer, would embed software into its teletext service, so software could be shipped over the air to remote machines with the teletext adapter, allowing you to download it and store it on, say, a cassette or a floppy disk, or, whatever storage you got attached to your BBC, all as part of a service called Telsoft. The sheer range of things you could do with a BBC and the software available for it and the add-ons helps to make the BBC, or at least as far as I'm concerned, the best computer for the home. But there's one last thing I want to talk about with the BBC that I think will convince the unconvinced among you. And that's that tube port I mentioned earlier. The tube port lets you add a second processor to the BBC Micro. So, for example, a second 6502. Now, this doesn't do multi-processing like you might think of now inside your machine, but it does let the BBC do something very special. So if we take this second 6502 to start with, when connected, that gives you a processor running at 3 MHz with 64K of memory. Now, you may be thinking, so what, we now have a slightly more powerful BBC Micro. Well, it's a lot more clever than that, because the processor inside the BBC is not switched off and out of use. That's now in charge of running all your I/O, while your second processor is just running the application code you want to run. So a fun example of watching this running at home is being able to run Tube Elite, the single best version of Elite out there for the 8-bit micros. But your second processor does not have to be a 6502. It can, for example, be a Z80, and when it's a Z80, the OS, when it starts up, will select whichever language ROM is Z80 compatible, and that's the one that will start up. So, for example, the Z80 version of BBC Basic. But of course, now it's got a Z80 second CPU, well, you can just run CP/M. So this makes the BBC the second machine in our list that can officially run CP/M in a way that's supported by the manufacturer. But of course, at this point, CP/M is maybe getting a little bit dated. So there was a 186 and 286 second CPU available, and that let your BBC become a PC. Yeah, it came bundled with Digital Research's DOS and even had the GEM desktop environment. But we're still not done with second CPUs from Acorn, as we had one based on an NCR chip, which let us run an operating system called Panos, which frankly is not very good. But probably the most famous of its second CPUs was the ARM microprocessor. Now, the really clever bit of the Tube and the second processor is this is all supported in its operating system. You're not installing any weird hacks or ROMs or anything like that. You just connect up the second processor, and the OS understands how to boot up with any second CPU. And this has meant these days we've seen a development called PiTube Direct, which is essentially a Raspberry Pi connected up to the tube port of the BBC, with a bit of software on the Raspberry Pi that lets it pretend to be all the second processors that the BBC ever had, or just lets the BBC talk to the native ARM7 CPU that's on the Raspberry Pi, which makes this the only machine on our list today where you can run Quake 2 and not have to modify your BBC. You just connect up your ARM7 CPU, and everything in the BBC just works the way it was initially designed to, as the idea was always there that you could connect up increasingly more powerful processors to your BBC. Now, I will say a second CPU is not something everyone bought for their BBC. It was a minority of people that bought it, but no other home computer had this kind of capability. And I do know of people who, at the time, had second processors for their BBC, largely the Z81, as they had a need to run CP/M. I hope you've enjoyed this listicle as much as I've enjoyed making it. And I promise my sole motivation was not to try and get this on This Week in Retro. Although if any of you want to pop onto their subreddit and tell them about it, because that's how they find things, feel free, because it'll amuse the hell out of me if this thing does actually get mentioned on there. But I would like to say thank you very much for watching. I'd also like to say a thank you to Lee from More Fun Making It, as he was able to sort me out with some B-roll footage of the correct versions of certain machines. If you want to jump in the comments and give us your list, then feel free. I'm looking forward to reading some of them. Although given the subject, I probably should say, play nice with each other, everyone. If you really enjoyed the video and you would like YouTube to know that fact, there is a button to indicate it. And if you really liked the video and would like to help the channel out, please feel free to subscribe, because it really does help the algorithm know that someone vaguely cares, and so it might want to mention this video to other people. Right, I'm off to go curl up in a bucket of Lemsip, I think.